people their use are. So to give that a little bit more meaning, I've stated here 2 examples before I can dive into the bigger example that I want to tell you about today. If we talk about service, one of our first projects that we did was called ARI, automatic routing of incoming emails, where we trained a neural network to decide what an email was about and to direct it to the right workflow, where the benefit was that an email would arrive there much faster than it did with the previous process, and it could be answered a lot faster. A second example that has more to do with the claim side is that we're helping our marketing department in understanding a little bit better what the added value of collective contracts is. As many of you listening here, you're probably employed somewhere and you might have collective health insurance through your employer. To be able to kind of justify the discount that you get through a collective contract, that discount could be up to 10% of the total premium cost, the health insurance company has to prove that there's an added value to giving you that discount. So by making a collective contract, you can, for example, provide additional service that will lead to a better quality of life, a better quality of care, or lower healthcare costs. So we're trying together with our marketing department to see if those effects also actually occur. And we did that by trying to cluster different smaller collective contracts to come up with large enough numbers to actually see some differences. For the coming year, that discount will be significantly lowered, by the way, to 5%, and it might, the year after, and it might totally disappear because the added value of these collective contracts hasn't been super clear so far. So that's why we're trying to use data science to see where we can either add more value by finding useful differences or prove the value that's already been added. So what I wanted to do today is to talk a little bit more about a big case that we've been working on this year. And the case is about predicting authorization requests. With authorization in Dutch, I mean machtiging. And most of the healthcare in the Netherlands can just be provided by the provider where you are. So, for example, when you have a headache and you feel like you need to go to the GP, to your huisarts, you can go there, he or she will send in a claim and CZ will pay it. Some of the healthcare, though, is a little bit more complex in its reimbursement guidelines. So, for example, if you need a certain type of orthopedic shoe, or if you need a specific denture within your mouth, your provider, your zorgverlener, needs to send in an authorization request, een machtigingsaanvraag. And based on certain rules within your policy, CZ will then accept or decline it. Now, this is a kind of an old-fashioned process, which also shows you a little bit here. A lot of this is still done on paper, and it's also a kind of a lengthy process where it takes a couple of days for one of our employees to look at this, to make up his or her mind. Sometimes additional information needs to be requested. The healthcare provider needs to go back into the dossier, look at the additional requests, send it back to CZ. CZ has to look at it again. So it's not the most modern process there is. So at the very early start of the data science movement within CZ, this was chosen as a very promising use case. And we kind of failed. And I want to tell you a little bit about what we did, what went wrong, and then I'll explain you a little bit more about our second attempt and why we feel now we're doing a better job. Because I'm a firm believer in learning from other people's mistakes, because we all make them. This is a new field, so I think it's very useful to share the mistakes that we make here. So what you see here is a very simplistic overview of the first try we did. So this is an authorization request for this thing that the woman has on her neck. I really don't know the English word for this. And as you see in the middle, there is a form that is being sent by mail. There's even something written down on there to the department. So we hired a consultancy firm to look at this. We even bought a trial version of very expensive data science and AI software to help us here. And what we immediately started doing is, okay, we need to get rid of that piece of paper ASAP. So what we did is that we were trying to not look at the complete process at once and reason back from the end results, but really starting at this paper form and trying to OCR it, trying to get the right information out of it, and then see if with some Python algorithm we could come to a decision to either accept or decline this. We spend a lot of time, so this is like already 4 or 5 years ago, right? We spend a lot of time on being able to process the many different types of pieces of paper that were sent in to our company. And we repeated that with other types of care where there were pictures of jaws, where the formats of the pictures were completely different. Sometimes it was close up, sometimes it was extremely zoomed out. There are many different X-ray machines. There are many different formats in which the pictures were sent to us. So we kind of got stuck at the beginning of this. And we managed to make some kind of prototype for very small types of care where we managed, but it never became a huge success. So very soon we kind of abandoned this topic and we went on to other use cases where we could easily add much more value, much faster, much cheaper. But in the back of my head, this example kept kind of like bugging me, like, okay, we promised that department something and we never really came through on it. So in the beginning of this year, we went back, or maybe even end of 2019, we went back to that department. In the meantime, that had changed managers, changed team leads, and we started discussions over again and asked, okay, we'd like a second try. Is that okay with you? And luckily we got it. So what we did in that second try was to, like what many of you probably do every day, but in the beginning it was a little bit hard. We really looked at much better at the ideation phase and looked at the end result of what we wanted to attain, and we didn't focus as much on purely the technique of extracting information from a piece of paper. So after lengthy talks with the manager and also the director there, we said, okay, using these predictive models, what's the goal there? The goal is to help reduce the waiting days and also reduce the costs of this process by increasing the efficiency of requesting an authorization. And if you look at this Dutch text here, this is on our website. It says within 10 working days, you can get a reaction on your requests. Sometimes we need extra information. If we approve your authorization, you'll get an email or sometimes even a physical letter with this declined or approved. So we want to change that into something that's much faster. We want to immediately give an answer to the request. And if we need extra information, we really want to minimize that, because one of the goals we have for our healthcare providers is to minimize administrative burden. A lot has been done on minimizing administrative burden over the past years, but we're definitely not there yet. There's still a lot of forms that might not make the most sense. A lot of people at CZ are working on this. I know a lot of people across the country work on that, but we're definitely not there yet. And some of this could be done in automation, where right now there's a lot of just manual labor still involved here. So what we wanted to work on by using predictive models is to reduce the waiting times for our members. Because as you can imagine, if you need something in healthcare, this is probably very important to your quality of life. You're not requesting for orthopedic shoes because you think they're very pretty, right? You're asking for them because you're hurting, or because otherwise you can't really walk as much as you'd want. So if you then have to wait up to 10 working days, that could be very stressful. We also want to provide fast feedback for the provider, because their time is limited and it's also expensive. So if they have to go back after a day or 5 to go back into the file, look for extra information, that is not like a customer-centric process. So we want to, if we need extra information, immediately be able to give him or her that answer and ask for the extra information. And obviously, as a tertiary goal, it would be great to reduce internal costs and also to better use our employees' knowledge. Because if we can filter out the simpler requests, they can work on the more complicated requests and also spend the time that they have left or that they will gain in talking to our members in, for example, searching for alternative options if unfortunately something would be declined. So those are the goals that we started with in our second attempt. And reduce manual labor. We also immediately came up with some kind of staging of where we wanted to go. So when we were having this discussion, end of 2019, everything was still done manually. And we had a very interesting discussion with the director of operations who said, I actually want to quit with this whole authorization process completely. That's my dream. I know it won't be 100% possible, but I'd like to go as far as possible in being proactive, in being able to predict what authorization requests will come in for who, and then somehow maybe open up those authorizations or those claims for that member for a specific time, or proactively let certain providers know that an authorization isn't necessary. But I want to be kind of in front of the ball, and I want to also be able to maybe guide or steer my members towards the best providers that I know for certain, because for certain types of care, we know a lot of the quality of the providers and we have a preference about where you get your service. So with that end goal in mind, we started working back and thinking, okay, so how can we, with this end goal, immediately start adding value to CZ, but also to the employees, without losing ourselves in super big algorithms of multiple years of predictions on where certain diseases will go. So we made a goal for 2020, which we have attained, in making a supporting tool for employees where they can get a prediction if an authorization should be accepted or declined. And then for next year, we want to embed that tool into the operational system. We're in the midst of changing operational systems or transaction systems. So for now, it's not possible to embed it, which also gives us the chance to further fine tune it and to make sure that it does what the employee wants and what CZ as a whole thinks is beneficial. So after really understanding in this exploration what was wanted, what was needed by the business, we thought it was, we were ready for making a prototype. And so this is the slide I was looking for. We did something else very differently than in the first attempt. So in the first attempt, we were kind of stuck on that physical letter, right? And OCRing it. And we thought, what if we just kind of ignore that letter and see if within our existing databases, we already have enough historic information from our members to determine if a request should be granted, yes or no. And if we could do that, we might even further lower the administrative burden by, for certain requests, no longer needing the hassle of the paper and the administration. We could just say to the provider, okay, we now have a new system where you just have to fill in the member and the type of care that you want to request, and immediately you'll get an answer. Because from what we already know from this member, we can give you, with a reasonable level of accuracy, a yes or a no, I need further investigation. I will come back to this, but this is very important, so I'm going to already stress it. This is a highly sensitive topic, right? Deciding on what type of care a member can get, yes or no. So in any data science AI model that we will ever use here, there are two things very important. And I will come back to this, but I cannot stress this enough. The first one that's important is that our algorithm can only say yes or I need more information. So, and with a yes, the advantage is very clear because it will get faster to the client and to the provider. So there's a definite gain, like a very clear gain for the member. If the algorithm isn't sure about the yes, might even be leaning towards a no, we have an employee looking at it and making that decision. The second The second very important condition here, which I'll also come back to, is that we don't want to use black box algorithms here. I want to be able to always explain why a decision was made, because this is highly sensitive. It can be life-changing for someone if you get, for example, a medical equipment device, yes or no. So I, as a data science manager, want to be able to explain to the operational manager why my model says yes to person A and no to person B. So later in this talk, I'm going to tell you more about the models, and we're using very basic decision trees because I want that explainability in there. So different approach. We're looking at the history, we're looking at the data we already have, and we're kind of ignoring all the papers and the pictures that are coming in. So in the exploration phase, we also did another thing differently. We really looked at the business process behind the authorization requests. And we divided all the authorization requests into these 3 categories. We actually found that there were lots of types of care where almost everything was almost always approved. And that the declines were sometimes with a specific set of healthcare providers or with a specific subset of the type of care. And we gave an advice to the department to greenlight those types of care and to really think if an authorization request is still necessary in this day and age for those types of care. Of course, an authorization request sometimes is a legal condition, so then it's something that CZ cannot decide. And there's also some precedent working in there, so it cannot just be switched off immediately, but we very clearly advised them to take a look at those types of care. Then we had a second category where there were types of care with high volume and a very generic set of characteristics of, for example, the types of providers that requested, the other types of healthcare that people that request this authorization have. And there we found that predictive models could very well be used here to make accurate predictions. Then we have a third category where the volumes were just too low or the heuristics were way too specific to train a model on. So we're focusing only on that middle category of high volume care with a generic set of characteristics. And for the other 2, we gave an advice to the operational department on how to deal with that. So together with the business, we then started building this flow to kind of take them along our data science journey and also explain to them what kinds of products we could make for them, and that there are separate deliverables if you're working on a data science solution. So obviously you start with the data, we're testing a lot of different models, and we've really included the business here on selecting the right model for the right type of care. And I'll come back to that later because it was a very important part of this process. We have already made an API for the integration once the transactional system is done. And we've for now made a supporting tool for the employee, which is a tool that stands alone from the transactional system, but is fully integrated with the data. So there's no manual labor there. And then, of course, we have some place, in this case, a dashboard where we track the results, and we also be able to have a feedback loop on how good our models are performing, and if that fits the wishes of the business. So let me start with the supporting tool for the employee, because we're really thinking from the end user here. And what we've made is, and I have a screenshot of that later, we've made a very simple front end where an employee has to give a number of variables, the client number, the type of authorization, the type of care that's being requested, the number of the provider that's requesting this, and the dossier number so that we can later link it to their system. And then that tool will give them an approve or an unknown where extra manual investigation is necessary. And as you see in the slide, I have added here 10% control. What we thought was super important is to not have some sort of self-fulfilling model here where we're forever going on the policy of 2019. So 10% of all the requests that come in aren't checked by the model, but are directly given to the employee, so that we will always have their current knowledge into the approval process. And that also gave the business managers a sense of control, and that they know that there's not a computer taking over their work, and that we're really working together with them to get the best answers. So this is what the tool looks like. What's very important for CZ, it might be a very stupid detail, but I've added here is a link with our AD groups, so that we really know that only the employees who have the rights to work with this highly sensitive topic can access the tool and can use the tool. Because we really don't want people to play with that here or to get access to sensitive information. So as I've just said, they're doing a data request where they're filling in very simple variables that they're now also filling in manually. So that wasn't a lot more work. And then they can click run here and they'll get an answer. So here the advice is to manually check. And then we ask them to give their feedback, because we really want to learn, of course, if what we're doing is also what they would do. So if this tool is working as we hope it should work. And this, so even though it's still a standalone tool and a supporting tool for an employee in our organization, it already looks a lot like a normal application. So it didn't feel like we were really just experimenting or prototyping. It really felt like we're already doing something in production. So if I go to the last step here, tracking of results, before we journey back to the beginning of the flow, we've made a dashboard where the manager can really look at everything that's happening, how well the models are performing, how many models have been used, how many authorization requests were actually handled, and it can zoom in per type of care or in total, really to get that management information you want when you're doing like really new things here that because it's important to really know what's going on and to keep track of the results. And then if a manager wants, he or she can zoom into a specific type of care and really look if things are going well, yes or no. So let me start at the beginning of the flow, now that I've shown you the end result, how we actually did this. So as I said before, we're using a lot of historic data. So we're not using a lot of information that's on the authorization request. And it was really an experiment for us, and it could have like very huge implications, because if this would work on a larger scale, we might even be able to stop with the forms and to really help the providers in lessening their administrative burdens. So the data we've used is of 3 different categories. We've looked at sociodemographic data, so the sex and age of our members, the type of insurance they have. We look at their history with us, so what other authorizations have they had before, and were they declined or approved, and what other types of claims, so what other types of diseases do people have. And here it's probably interesting to know, for those of you that aren't super familiar with our data, is that we have obviously all the claims of all the different types of care, but the claims are mainly used for financial reasons, so they might not always contain all the detail that you know. So if I go to the GP because my knee hurts, later in the database of CZ, you can see that there's been a consultation with the GP at a certain date, and it'll tell you something about the length of the consultation. If it be a short or a long consultation. There will not be any information in there about my knee or about the reason I went in. For other types of care, this information can be a little bit more elaborate. For example, in hospital care, I know much more about why someone's going in. I know, for example, if you've been admitted to the hospital, I know if there's been an operation, I know if there's been an ICU admission, but there's also a lot of the more deep medical knowledge that I do not know. For example, I do not know if the type of cancer, for example, that someone might have, or what exactly was done in an operation. So that's about the history. And then the last category is about the provider, so the zorgverlener. And what we've done here is that we've created a new variable called the provider score, where we very simply calculate how much of the requests that a provider sends in have been granted. So that gives us kind of an idea about how good the quality of the authorization request is. And here we've struggled quite a bit if we should do that per like the lowest level of type of care, or if we should do that at a general level. And we've really like played with a number of different options here, and also talked to the business to see what would work here, yes or no. So that's about the data. Then towards the models. We've made a couple of different options for models where we played around with combinations of variables. And then with those options, we made different decision trees. So we have a reference model where we look at the socio-demographic data and the history in authorizations. So that's always in there. Then we have a second option, a claims model, where we have the reference model and we add more specific claims history. So for example, why would that be relevant if, for example, there is a request for me for ventilation at home, and I don't really have any previous requests on that, but in my claims history, you can see that I'm a lung patient. That might really tip the scale towards a yes or no, right? So the claims history can give you more information about the underlying diseases that someone has that haven't been portrayed by previous authorization requests. Then the third model is the reference model again, where we add that provider score to get some insights in how well a provider has in the past operated with the authorization requests. And then the fourth option is to combine everything. And for different types of care, a different model might give you the best performance. So that's why we're giving all the options. So what we've done is that we've made also a nice front end here where we could talk with the business manager and the responsible process coordinator about the different outputs that the different models will give you per type of care. And this is an example about the type of care alarm, where you can see the performance of the different models. And as you can imagine, this really took some explaining to the business manager how this should be read, what actually is a good model, what false positives are, what a confusion matrix is. So this really took a lot of explaining, and it was really, really important for us to totally understand their process, and it was important that they totally understand that a model cannot solve everything, cannot catch everything, and that there's always kind of a balance between how good you want your model to perform, what false positive rate, for example, you find acceptable, yes or no. So this has been a very insightful process throughout this whole case. So then to give the business also a lot more insight in what was actually happened, we've also visualized the decision trees per type of model for them to really help them understand how the reasoning of the model was, also to make sure that that the business logic was correct. And then so this is an example here, and then what they could also see here is what the benefits would be of choosing this model. And the benefits for this use case are reduction of waiting days, and also what a reduction of waiting day would cost, and how secure we were that what the model said was really true. So this was really, really a hard thing to do with the business, but it was super useful. And it was also super useful to explain to them that the backside of using a model here is that you might incur extra healthcare costs because there are going to be requests that a model might approve that a human might not have approved. Of course, if everything is manually done, this also happens, but then it's not super visible. By explaining to them and really being super transparent about the performance of your model, you're really pinpointing, okay, if this is a decision you're going to make, then out of every 100 requests, 6 might be granted that a human might not have granted, and that'll cost you so much. It also gives you a reduction of 100 waiting days, and it'll save you in your FTE. But that's really like a mind shift for people whose work it is to make sure that the authorization process is as professional as possible, of course. So that this was super interesting in this use case. So after the models had been selected by the manager, we set up the tool for a number of test persons of one of the teams in that department. And per type of care, we set up a threshold value of how accurate the performance needed to be to make sure that beforehand we knew if we would approve this, yes or no. And luckily, we had for every type of care, we exceeded that. So from that point of view, we could definitely proceed. Obviously, we also encountered some data issues because when working with the employees really in that tool, we also found that sometimes the process wasn't as easy as we had thought from the previous talks, that sometimes requests are linked together or bundled together, that sometimes the code of the provider doesn't make any sense, or that there are other missing data. So obviously always data issues, but not to such an extent that we didn't feel like we could go on. And it was really nice because this was the first time that we really made such an effort to make an actual tool for the employees that they really found it very nice to work with. It works simple, it works fast, and we got a lot of suggestions. We got some suggestions also to make the UI better. So that was really good. It was a really positive experience. So in conclusion here, we've made this fully automated standalone tool to support our employees. Per type of care, we can select a different model together with the business to make sure that per type of care we're doing what's really ideal for the specifics of that type of care. And that's also linked to the last point. You have to really combine the specifics of the type of care. And what I mean there is to really understand, okay, will one false positive here lead to $1 million in unrightful healthcare costs, for example, versus like a member waiting 10 more days, and not only looking at the accuracy of your model. So this is really just like a combination with the business perspective and the data science perspective that the best performing model might not always be the best business decision. And that's really what my department has learned here, which has been like very meaningful for us. So what's next? We've done this now for a number of different types of care, and we want to, of course, scale that up to include more types of care. We're still thinking if we could maybe add even more features to make the models better. We've done a lot in pre-computing so that the tool is super fast, and yeah, we still see a lot of possibilities to make that even better. And we want to further enhance the architecture of our tooling. I have, I think, a clip of that later on, what we've used now. And also that was a first for us. And then, of course, for next year, we have the integration with the new transactional system. Oh yeah, this is our high-level architecture. I won't go into that, but if people find this interesting and would like to know more about that, I would definitely invite you to contact me, and I can set you up with the engineer or the scientist to talk a little bit about that. As you see, we're a huge fan of Docker and Airflow, so we've used that in this prototype that's pretty high level, I'd say, right? So it's I started this talk by saying that we made a prototype, but we feel that we're really very fast moving towards a super mature solution here. So then the not so sexy part of this use case, the conditions, legal, ethics, but definitely very important, especially in the healthcare business. Of course, GDPR is always an issue when we talk about healthcare, and especially when we talk about something so sensitive as authorization requests. So I've already said we're only using transparent algorithms. We have talked about this with our compliance officer, and we feel that by even if a decision tree isn't super simply explainable in one sentence to every layman, that the way we set it up now, we can definitely always explain why a decision has been made. We will only have the model say yes, right? So that super fast service with a portal for the provider will only give you the gain for the yeses, and then everything that needs to be investigated will go to the normal process. And of course, the benefit there is that the under investigation cases might go faster because all the yeses have been taken away by the algorithm. And as I've also mentioned before, we're excluding 10% of all the incoming cases from this method to make sure that we're not falling into some sort of self-fulfilling prophecy, and to really take into account also the latest insights that our employees might have. But apart from legal conditions, we really think it's super important to also talk about ethics here, because this is so sensitive. And I've included this slide. I've never actually shared this during a talk before, but this is a translation that we as a team made from a new framework from our from the Verbond voor Verzekeraars, because they have set up some sort of guidelines/framework what questions you should ask yourself when you're talking about AI and ethics. And some of these principles here are kind of already captured into the GDPR, but some might not be. So I'll go over it. So the first step in this ethics framework is human autonomy and control. So we're always doing data privacy impact analysis for every use case that we do. So you need to let people know that we're using AI. A couple of weeks ago, I don't know if you've seen it, the Municipality of Amsterdam has published like a very beautiful website of their algorithm registry, where they're super transparent about everything that they do. We want to ensure technical robustness and security. That's not super ethics related, right? Because for every IT data science solutions, you want to make sure that that it's robust, but it's in this framework as well to really also check. We want to make sure that privacy and data governance are very well protected. And then it becomes a little bit more ethics related. We want to talk about transparency, so we want to really use explainable models, and we want human intervention to be possible if the model is doing something that is not desirable. We want to make sure that we're preventing unjust bias. So we want to really think when designing a model about non-discrimination. So as an example here, my team has also worked a lot for the debt department, so people who have not been able to pay their CZ bills. And we're working on personalized services to nudge people towards contacting us and kind of getting over their fear of talking about finances and picking up the phone and trying to arrange this. Here, it's very important that you're not, like, even without knowing it, discriminating, for example, against certain ethical groups because you see, based on a postal code, that you're choosing an approach, and in that postal code, there are more groups of a certain ethnic background, and you might, without wanting it or without knowing it, fall into like a discrimination trap, right? So we really want to make sure when we design our algorithms that we think about this. That doesn't mean that we'll never make a mistake here, right? But we are very much aware that it's very important when designing something that you think about this. We also want to monitor the social impact. So if you're designing a solution, to make sure that you're not excluding groups, that you're not doing something unjust towards a specific risk group. And the last one is accountability. So it's very important, especially with AI solutions, that you log everything, that you are very transparent, that if a complaint comes in, it will also really be linked to the fact that we're now using a model, so that we can immediately check if things are going well, or if accidentally mistakes are being made, yes or no. So that was most of what I wanted to share with you about this use case. And I think Luz has gathered some of the questions.
Yes, sure did. Very first of all, thank you so much for your presentation. It was very clear and very informative. I have to say that we got quite a lot of questions, so I'm afraid we cannot really handle all of them. And maybe some are answered during your presentation, so we'll go by some. Let's first start off with a question from Jan. He asked, how do you manage the different interpretations of the data in your input? And what elements are the key to success of your data science projects?
So I guess the key to success to any project is to make sure it's being used. Right? So really early on, get a feel if this is just a fun side project for a department, or if they're really willing to change their process and start using the solution that you come up with.
Great, thanks, Fleur. Furthermore, Renate is wondering, do you retain the model with the input if the model says no, but the employee says yes?
Then that's super useful for us, right? Because that feedback will be fed back into the model. But if it happens a lot, it's also very interesting to look if those are exceptions, right? So if an employee sees some circumstances that our model doesn't see, that we need to take into account, or if we've tuned our model wrongly and we need to change that. So that's definitely something that we'll look at. But the decision will ultimately always be with the employee.
Yeah, clear. Next question is from Ander. Which predictive models/data mining techniques do you use?
So at my department, we use a lot of different techniques. So for example, a lot of NLP-like models. We've used LDA for topic modeling. We've used neural networks for deciding the right workflow. We've used clustering algorithms for the collective contracts. We also use a lot of regression techniques. We use a lot of Monte Carlo simulations for evaluating e-health innovation projects. We've used Markov chains for fraud detection. We use a lot.
Almost everything. Great, clear. One more frequent question is, which tools do you use furthermore? Well, I think you shortly discussed it as well, like the Docker and the Airflow. I saw also Python, Combine, Hadoop, Spark. Well, if they have any questions, they can ask you, right?
Of course.
Perfect. Next question, also from Renate. How do you ensure GDPR compliancy with your data?
So a lot of the data we use are from the data warehouse. So there, the GDPR compliancy is arranged there. So for example, we don't use, we've used like masked member numbers, for example. We don't have access to some of the personal information that we don't need. So that's really in the data coming in. We also use some data from sources that don't come from the data warehouse. So then we have to ensure that ourselves within the Airflow jobs that we make to get it towards our cluster. And then for the for every case we use, we make a data protection impact, the data privacy impact assessment together with the compliance officer to make sure that what we're doing is GDPR compliant.
Great. Good. Thank you, Fleur. Let me see. Another question from Jeroen. How do you deal with bias such as drift bias, automation bias, ethical bias, etc., in terms of process?
Yeah, well, so what we try to do is just at the beginning of a case, think of all the bias or the ethical drawbacks that could occur if we use data science. So what we usually do is we have a workshop with the business and our data scientists to really think of the drawbacks and the darker side of using AI data science. And then based on those findings, we make sure that when we design the use case, we don't fall into those traps. A lot of the cases that we've worked on, bias hasn't been that big of a danger, I guess. So I don't have a lot of good examples of how we handle that.
Okay, clear. Let's move on to another one. I have here a anonymous attendee. He ironically asks, how could you prevent insurance fraud if users may learn to understand and influence the decision tree?
Yeah, that's a very good question. And it was also one of the main concerns when we talked about automating that. So what you have to bear in mind here is that it's providers, right, that are sending in the requests. So they have already from their medical authority decided that this might be a good idea. So it's not a place where typically a lot of fraud occurs. So what we feel is that for that small percentage of people who want to fraud, it would be wrong to have the whole system wait very long and not benefit from what we can do with AI. So we've decided to kind of like take the risk and do that. And it is very true that you could try to game the system and see how you can fraud this. But also, to be honest, in the way we've set it up now, where you look at historic data, that historic data won't change, right? So they're not filling in a lot of the features that will change the decision, because you cannot change the age of the member, you cannot change the historic claim data of the member, you cannot change your own provider score. The fraud might even be decreased when you're not looking at that form, where you can also kind of play with the things that you fill in.
Yeah, clear. Good. Let me see, we have a lot of questions regarding the decision tree. Are there any features to be added, improved, or which currently face seemingly unfeasible challenges?
So can you repeat this? Because I was
sure. About the decision tree.
Yeah. Mm-hmm.
Are there any features to be added, improved, or which currently face seemingly unfeasible challenges?
Yeah, we're investigating now what features could be useful to add. So it could be useful to add more specific details of someone's medical background.
Yeah.
But you have to also bear in mind, some people think that we are huge in what information we have of you. So I had a talk with a hospital last week that thought that we had like a risk score of every member based on their potential smoking behavior or weight. We don't know stuff like that, right? So there's a lot that we don't know. So we've really tried to maximize everything that we already have. But it's always interesting to see if we can add features, but I wouldn't really know for now.
Yeah. Clear. Let's go to the final question. That one is from Mark. What are your predictions regarding data science, AI, and machine learning, which may influence the future of health insurance companies?
Yeah, that's a tough question, right? I'm definitely agree that that AI will influence the business model of a health insurance company, because if you can even better predict what type of disease someone might get or might not, or what type of cost someone might have, the business of insurance, which is about really reducing uncertainty, that doesn't really coincide, right? So we together with JADS, actually, Geronimus Academy of Data Science, are also investigating the future business models of health insurance companies, given that AI and data will play a larger part in our life. I think for the short term, it won't change that drastically. It's my personal opinion, because we're in a pretty good system already, right? So if you see some of the data science AI that can really change healthcare, I see a lot of opportunities there, but we're already doing a pretty good job. It's not like there's not enough healthcare here, right? Everyone has good access. So I don't see it going from year 1 into year 2, but it's definitely interesting to follow. I think if you're interested in that, Lucien Engelen made a very nice webinar from the Disruptor channel or Disruptor League or something that you can look back on YouTube.
Great. Thank you for your recommendation as well. Well, let's wrap up. Fleur, I want to thank you so much for your time and your presentation. I think I speak for all of us who watched today. I think it was very informative. I also would like to invite everybody to join our meetup page for all future webinars and meetups when it's possible again. Here's the link. We'll also send that to the ones who don't have it. And furthermore, if you want to watch it back, we will be providing this webinar on YouTube, and you can find the link afterwards. For now, I would like to thank everyone for their time, especially Fleur. And yeah, let's see you at the next webinar. Bye-bye.